10, 9, 8, 7, 6, 5, 4, 3, 2, 1.
Hello everyone, welcome to Mechanical Sathi. Today in this video we are going to discuss 10 MCQs which may be beneficial for those students who are preparing for Vizag still this year. So randomly we will be picking some questions. So daily we will be uploading one video on this. So do share this with your friends so that they can also take benefits from this video. So do watch till last. So around 10 questions we will discuss here. So without wasting time, let us move forward and start our discussion. So for that reason, first question is that which of the following mechanism generates intermittent rotary motion from a continuous rotary motion? So options are given like Scotch-Yoke mechanism, Geneva mechanism, and elliptical trammel and Whitworth mechanism. So from all these four options, Geneva mechanism is transferring from the continuous rotary motion to a intermittent rotary motion. So that means we can say a continuous rotary motion is being transferred to intermittent rotary motion. So here option 2 will be the correct answer, that is Geneva mechanism. So let us see the construction, how it can transferring. So there are some parts like this is the driver wheel and this is the driven wheel, that is also called as the Geneva wheel, and on the driver wheel there is a pin. Okay, so when this pin is transferring or moving from this point to this point, then only or at that time only this Geneva wheel will be moving. Okay, and during the rest of the year it will be in the stationary position. So that's how your intermittent rotary motion is achieved over here. So this is the table of spindle for the Geneva wheel. So let us see a animation video so that we can get concepts our clear. Okay, so see this. So here we can see that when this pin is moving from this point to this point, means from here to here, at that time only this Geneva wheel is rotating. Okay, so I think it's clear to clear to all of you. Let us see it again so that we can understand it in a better way. So let us see it. When this pin is moving from this point to this point, at that time only this Geneva wheel is moving, so that that's how we can get a intermittent motion from a continuous rotary motion. So continuous rotary motion is given in the driver wheel, and we are getting a intermittent rotary motion in case of your Geneva wheel. Okay, so moving next towards the question number 2. So question number 2 is asking that in a higher pair the relative motion is what? Options are given like purely turning, purely sliding, or due to surface contact, or the combination of sliding and turning. So we know the higher pair means there may be a point contact or line contact. Okay, other definition we can say in case of your higher pair we will be getting the combination of sliding and turning pair. So option 4 will be the correct answer for this question. So let us read some details about it. So higher pair, when two elements of a pair have a line or point contact, when relative motion takes place and the motion between two elements is partly turning and partly sliding, then this pair is known as a higher pair. Okay, so basically in case of your higher pair we'll be getting a combination of sliding and turning motion. Okay, so for this question option 4 will be the correct answer. So question number 3 next. So it is asking about the pitch point. Okay, so basically it is asking what is a pitch point. So let us read it. The pitch point on a cam is what? Okay, options are given like any point on the pitch curve, or the point on cam pitch circle having the maximum pressure angle. So this is the correct answer. So the point on the cam pitch circle, okay, so it is a point on the cam pitch circle having the maximum pressure angle. So at the case of a pitch point, your pressure angle is maximum. So option 2 is the correct answer. So let us read all other options also. So the point on the cam, that cam pitch circle having minimum pressure angle. So this is not the correct answer, and none of this, obviously it is not correct. So we can see here option 2 will be the correct answer. Okay, so let us read some points about this. That pitch point corresponds to the point of maximum pressure angle that we discussed now. Okay, and a circle drawn with its center at the cam center, that is known as your pitch circle. Okay, to pass through the point, the pitch point is known as the pitch circle. And the pressure angle is the angle between the direction of follower movement and the normal to the pitch curve. Okay, so I think you got idea about the your pressure angle also. So pressure angle is the angle between the direction of follower movement. So the angle between the direction of follower movement and the normal to the pitch curve is known as the pressure angle. And at that point where it is maximum, that is pressure angle is maximum, that point is known as your what? That is pitch point, and that point should be on the pitch circle. Okay, next question number 4. So the interference between the teeth of two meshing involute gears can be reduced or eliminated by options or statements are given like this: increasing the addendum of the gear teeth and corresponding reducing the addendum of the pinion. So obviously by doing this we can we can eliminate, okay, or reduce. Okay, so interference can be reduced by doing like this, that if you will be increasing the addendum of the gear teeth, and again if you will be decreasing or reducing the addendum of pinion, then we can reduce the interference between, okay, any gears and pinion. So here we can say option 1, that statement 1 is correct. Okay, so let us check option 2 also, that is statement 2 also. So statement 2 is telling like this: reducing pressure angle of the teeth and the meshing gears. No, so by this we cannot reduce the interference between two gears, that is involute gear and pinion. So here option 2 becoming as wrong statement. So let us check what is it asking for. So which of the statements given above is correct? So obviously we got idea that that is statement 1 is only correct. So that option 3, okay, option 3 will be the correct answer for this question. Okay, that is only 1. Okay, so here we can see option 3 will be the correct answer. So moving next, that is question number 5. So what is the main purpose of a flywheel? So we know what a flywheel does. Okay, so basically flywheel is used in any engine, okay, so to get a constant torque, okay, or uniform torque. Okay, so in case of your other strokes, excluding the power stroke, we are not getting any power from the engine. So to keep moving our shaft, okay, that is crankshaft. Okay, so to keep moving that crankshaft, that means to maintain a uniform torque, we need to use flywheel. So that is the main purpose of flywheel. That means option A, that is option 1, it is telling that it is used to maintain a uniform torque from energy flow is not continuous. Okay, So when energy flow is not continuous, to maintain a uniform torque in any shaft, we are using the flywheel. So option 1 is the correct answer for this question. That is question number 5. Okay, so how is it doing so? So it is having with a mass, higher mass. So by using the inertia of it is doing like this. So option 1 will be the correct answer for this. So let us read all other options also here. That it controls the mean speed of engine when load is changing. So it is not the function of flywheel basically. So it is the function of governor. So we are not discussing about governor over here. So it is asking about flywheel. So it can't be the answer. Okay, so it cannot be the answer for this question. So option 3, it is used to control the external fluctuation and vibration. So it is not the answer also. And it is used to provide the uniform acceleration. No, it cannot be the answer also. So for question number 5, option 1 will be the correct answer. So moving towards next question, that is question number 6. So okay, so let us okay, so now it is asking something about the governor. So let us read it. A governor will be stable if the radius of rotation of balls. Okay, so governor will be stable if the radius of rotation of the balls. Okay, so options are given like this: increases as the equilibrium speed decreases. No. So your governor will be stable if the radius of rotation will increase when your speed increase, or your radius of rotation decrease when your equilibrium speed decrease. Okay, so let us check our answer like these options. Okay, so 1 cannot be the answer because it is telling that radius of rotation is increasing as the equilibrium speed is decreasing. No. So decrease, that is radius of rotation is decreases as equilibrium speed increases. So it cannot be the answer also. So let us check option number 3, that radius of rotation of the balls increases as the equilibrium speed increases. So we can say that option 3 will be the correct answer. So okay, so we can tick option 3 as our correct answer. And let us check option 4 also, that remains unaltered with the change in equilibrium speed. No, if it will be changing the equilibrium speed, then obviously our radius of rotation of the balls should change. Okay, so option 3 will be the correct answer over here. Okay, so let us read some important notes over here, like what is the condition of your stability. Already we know about that, and we have discussed about that, and special cases like haunting and all those, let us try to read. Okay, so stability of governor. Okay, so a governor is said to be stable when every speed, okay, within the working range there is a definite configuration. Okay, so for a particular speed. So here it is telling that for a particular speed there is a particular or definite configuration, and there is only one radius of rotation of the governor balls at which the governor is in equilibrium. Okay, so obviously for a stable governor, if the equilibrium speed increases, the radius of governor must also increase. So that already we have discussed. So next we can discuss about the isochronous governor. Okay, so what is a isochronous governor says? So a governor is said to be isochronous when the equilibrium speed is constant. Okay, so that is equilibrium speed is constant, and that is range of speed is 0, and for all radius of rotation of the balls within the working range and neglecting friction. Okay, so basically it is not the stability condition. Okay, so a governor is said to be isochronous when equilibrium speed is constant for all radius of rotation of balls within the working range. Okay, so when your equilibrium speed is remaining constant for all radius of rotation, then that condition or that type of governor is called as your isochronous governor. Okay, so basically isochronism is a stage of infinity sensitivity. Okay, so you can understand it. So another case is the hunting governor. Okay, so a governor is said to be hunt if the speed of engine fluctuates continuously above and below the mean speed. Okay, so basically the speed of these two or these balls, it is fluctuating continuously above and below the mean speed, then that type of condition is known as your hunting. Okay, so you can get some idea from this. So let us move towards next question, that is question number 7. So we need to find out the degree of freedom for this mechanism. So let us see what are the given. Okay, so basically we can see over that there are 4 number of links, and joints if we calculate, then this is 1 and this is 2, 3, 4. So as well as there are also 4 number of joints. So for finding the degree of freedom, we can simply use, so that f is equal to 3 into n minus 1 minus 2j, okay, plus h, okay, or h, that is the number of higher pair. So we can see that there is no higher pair, so it will be tending towards 0, and so we can write f will be equal to what, 3 into n minus 1, that is equal to 4 minus 1, that will be equal to 3 into 3 minus 2 into j is 4, okay, so that will be equal to 9 minus 8, so that will be equal to 1. Okay, so here you can see degree of freedom we found out as 1. Okay, so option 2 will be the correct answer for this question. Okay, so option 2, that is 1, will be the correct answer. So moving towards next question, that is question number 8. So here let us read it. So compare two gears with a 20 degree pressure angle involute full depth teeth. Okay, another case is that those with 20 degree pressure angle with a stub teeth have. Okay, so statements are given like this: smaller addendum, smaller dedendum, and smaller tooth thickness, and greater the bending strength. Okay, so if we be comparing with the same angle, that is that is same pressure angle, okay, which is given as 20 degree, and we are comparing with a gear with involute full depth teeth, another is your stub teeth. Okay, so in this case in case of your stub teeth, obviously there will be smaller addendum, okay, as well as your smaller dedendum. Okay, but there will be no smaller tooth thickness. So option that is statement 3, we can say this is wrong, and option 1, 2 can be the correct answer. Okay, so another thing is option 4 is telling that greater bending strength. Okay, so obviously if your that addendum and that is your dedendum is small in case of your stub teeth, okay, stub teeth, then we can say to avoid interference, what we need to do, we need to decrease the size or number of teeth in case of your that is pinion. Okay, so to avoid interference, we have to decrease the number of teeth or the size of the pinion. So it will be decreasing the size of the pinion, so obviously we'll be getting the greater bending strength. Okay, so if its size is smaller, then we can have a strength will be more. Okay, so option 4 can be the correct also. So if we'll see statement 3 is wrong only, and statement 1, 2 and 4 are correct. So we can match with option number 2, that option number 2 will be the correct answer. So here you can see that option 2 will be the correct answer for this question, that is question number 8. So we can read some statements over here, so to clear some of the concepts. So in case of your 20 degree stub involute system, the gear is in the system have subtly addendum and subtler dedendum also. So the interfering portion of the tooth, that is a part of addendum, is thus removed. Okay, so therefore these teeth have still small interference. Okay, so we'll be getting a small interference in case of a 20 degree stop involved system. Okay, so for that reason, due to small interference, so minimum number of teeth on the pinion to avoid the interference is 14. Okay, so since the pinion is small, the drive become more compact and the stop teeth are longer, that is stronger than the full depth because of smaller moment or bending force. Okay, so that's how we can say our stop teeth have the greater bending strength. Okay, so I think you got some idea about this. So let us move towards next question, that is question number 9. So let us read it. So with symbols having usual meanings, the single degree of freedom system. Okay, so this equation is given that mx double dot, okay, that m acceleration, m into acceleration into c into x dot plus kx, that is equal to f sin omega t represents what? Options are given like this: free vibration with damping, free vibration without damping. So if you will see, it is a free vibration case. Okay, is it a free vibration case? No, because in the right side we are having some force. Okay, so we are continuously applying f sin omega t force. Okay, so it is not the case of free vibration, so it is the case of your force vibration. Okay, and in all those options we are having with damping or without damping. So if we check, c is here. Okay, so damping factor, that is c. Okay, so c is here, so we can say we have considered the damping over here. So it is the case of your forced vibration and with damping. So we are matching with option number 3, that is forced vibrations with damping. Okay, so here option 3 will be the correct answer. So moving towards next question, that is question number okay, so let us check it. So here we can check that option 3 is the correct answer. So this is the last question for this video. Okay, so let us read it. So if the size of a standard specimen for fatigue testing machine is increased, then the endurance limit for the material will what? Okay, so options are given like this: have same value as that of the standard specimen, or it will increase, or will it decrease, or none of this. Okay, so what is it saying? That if any size of any standard specimen which is being tested in a fatigue testing machine, then if size will be increased, then what will be its effect on the endurance limit? Okay, so answer we can say it will decrease. So how? So basically, if will be increasing the size, okay, so any specimen may be having with your surface finish. Okay, so it will be increasing the size. Okay, so what may happen? Your surface finish may be poorer. That means if in case of your smaller size, there may be some that is impurities. Okay, and that may be that surface finish may be poor. But if will be increasing the size, obviously that surface which was poor previously, that will increase. So that will give rise of the stress concentration factor, and if stress concentration will increase, then obviously your endurance limit will decrease. Okay, so what do you understand by endurance limit? Basically, it is the limit up to which any specimen can withstand the cyclic load. Cyclic load means, so let us understand what any cyclic okay, so what any cyclic load means. So suppose this is any spindle. Okay, so okay, so this is any spindle, and what we are doing, we have connected a shaft over here. Okay, so in this spindle we have fixed this shaft. Okay, and this spindle is rotating like this. Okay, so due to the spindle rotation, this specimen will also rotate. Okay, and suppose we are applying some load over here, then what may happen? So for a particular time, what is happening? in this upper part. So in this upper part is load is being applied. Then for some other time we can say in this part. Okay, so if we'll be considering this stage now the load is applied in this upper part. Then when this will go down, okay, during revolution or rotation, this will go down, and we can say and this lower part will come up. Okay, so at that time what we can say, your load is being applied in this part also. So application load is changing, so we can say this type of condition is known as your cyclic load. Okay, so what do we understand by your endurance limit? So the limit up to which any specimen can withstand the cyclic load. Okay, so obviously if will be increasing the size of the standard specimen, your endurance limit will decrease. So for this, your option 3 will be the correct answer. So let us read it, and we can get some good idea about this. So when surface finish is poor, there are scratches and geometric irregularities on the surface. Okay, so if surface finish is poor, obviously your scratches and some irregularities may be present on the surface of that specimen, and these surface scratches serve as the stress riser or that result into the stress concentration, and the endurance limit is reduced due to the introduction of stress concentration of these scratches, obviously. And when the machine part is larger, then greater is the probability of flaw exist. Okay, so if machine part is larger, then there may be flaw exist. Okay, so where will it exist? That is somewhere in the component. The chances of fatigue failure will be originating at the flaws are more. Okay, so where will be there your flaws? So at that region we can that probability of that is chances of fatigue failure will be more. Okay, so that's how we can say the endurance limit reduces with the increasing size of the component. So with this we reached at the end of lecture for today. So here we discussed 10 questions. So every day we will cover 10 questions randomly from any subjects we may get. So basically today whatever we discussed, most of the questions were from the theory of machine and design like this. Okay, so randomly we'll be picking up 10 questions and we'll be trying to solve. So do watch it and till the examination which is going to be conducted. Okay, so that at least you can practice 10 questions. So whenever you are watching these videos, then after seeing the question, try to solve by yourself. That for that you need to pause this video and try to solve by yourself. Then after solving, do watch the video and do get the solution. Okay, so do share with your friends whoever preparing for any mechanical related exams. And if you are new here, then do subscribe our channel, that is Mechanical Sathi, and press on the bell icon so that you will be getting all the notifications from our channel whenever we will be uploading any new video on this. Okay, and most important thing, share it. Okay, so share it as much as you can. Okay, so thank you for watching.